Welcome to my tutorial video where I will show how our cranes and our crane toolbox will help you to position and set up the crane in the desired lifting position when you are preparing a handling study. Let's start by opening the sample plant. In this plant I have colored everything gray, only the air cooler is in blue. That is going to be the subject of our lifting today. I will begin by appending the sample crane. This is the crane that you can download from handlingdevices.net under free sample menu point for your own tests, and I will bring it to the desired lifting position. So I have my crane in a decent place on the pavement, all the outriggers extended to the maximum. The jib on the crane, I will hide the jib. I open the superstructure, I open the boom, select the jib, and I will just hide the jib from it. If this is our crane position from which we are going to lift, and this is the position of the item to be lifted, the first important step is to measure the distance between center point of the crane. This is the center point of the crane. Each one of the cranes have star signed dot on the top, and let's find the center of gravity. It's going to be a very nice choice right here. So right now I have three distances, x, y, and z, and all the x's, and I'm going to write down these numbers because we are going to input this into our toolbox. That's going to give us how long the boom should be, what should be the boom angle, and what should be the superstructure turning angle, rotation angle. Let's navigate the browser into handlingdevices.net in the usage under toolbox. We can input these values and have some results. We're going to have these numbers resulted. So step by step, the crane is pre-selected. Clearly you can select any other crane, but as this is our free sample, this is the pre-selected crane. The first question, if we are lifting over the cabin or over the back. Right now we are lifting over the cabin. Hook clearance is or desired height of the boom tip from the equipment that we are lifting. I will need a spreader, I will need some chains. Clearly all this is on your handling study assumptions in your lifting strategy. Right now I'm going to choose 15 meters, which is quite a realistic hook clearance. I click on calculate, and we have our three most important number. Are the telescope extensions is specific to this model that you have chosen. The second important number is the boom angle, because that's the second step to turn the boom. And the third number is the superstructure rotation angle. Let's start using these numbers. The first number is extension. Let's extend our boom. From our menu, I'm going to select the seventh piece of the boom. Our telescope is numbered from the counterweight, so number 1 is always the first one, the highest number is the last one. Right now I'm going to move the highest number. On y-axis, all the numbers coming from the toolbox are in absolute values. Clearly the mechanical handling engineer has to decide if that's a negative distance or it's a positive distance. In this case it's a negative distance. This is the extension. Right now all boom is fine. Our first step has been done. The second step will be to rotate the boom, lift the boom. In order to lift the boom, on each one of our designs, the boom hinge is very clearly signaled. This is the star signaled point. This is the boom hinge. This is going to be our transformation center for the rotation of the entire boom. Best practice right now here. First, I will change to orthographic view, and second, I will just section out my crane. This helps with the box section. Let's fit the selection. I sectioned out my crane, so now I have a very nice and easy view about the center point, the rotation point of the boom. I select my whole boom because this is what I'm going to lift. Item tools, rotate, transform, and I'm going to put my transformation center onto the rotational center of the boom. That's why it has this star shape, the marking, because right now with this one you can put it very nicely into the center point, and now you have a decent rotation. Now I'm going to input the number that I have received from the toolbox, which for the boom angle is 28.5 degrees. Around the x-axis, I'm going to rotate it minus 28.5. Excellent. As we can see, it's now pointing upwards. This is done as it should be. Second step is finished. Now the third step is to rotate the whole superstructure of the crane. The whole superstructure of the crane is going to be rotated around this center point. I will select the superstructure. I will move the center point of the transformation to the center point. And I'm going to rotate around the Z minus 11.50, and we are done. Our crane is positioned, extended, and put right in the position where it can lift the air cooler. From this point on, you can make your renders, screenshots, however you do it, or just save the MVF files as is desired. I hope that the tutorial was clear. I hope you liked the features of our crane, and I hope to see you among our clients.